Hi guys, good evening. Still a handful of people needs to still join. Let's wait for 1 2 minutes. Let's check the status and WhatsApp, YouTube, what's happening over there. Today I plan to start with Doubly linked list, and then we'll try to convert that into a binary tree or binary search tree. Okay, so let's start. Let me know once you're able to see my screen. I'm sharing my paint screen first. So once you're able to see my paint screen, please shout out or post on the chat that you're able to see the screen. Yes, no, maybe. Would prefer if the YouTube guys would, the Zoom guys would reply. Is my paint screen visible to the Zoom candidates? If yes, please post a thumbs up or say post a yes. Has Revant joined? Jignesh joined? Yes, Revant, is my paint screen visible to you? Okay, let's start. So today we'll start with the doubly linked list. And this doubly linked list forms the core of the tree data structure. So we'll do that also. If time permits, we'll start with tree also. So in doubly linked list, why is it called doubly? Because it has 2 pointers. One which points to the next one and one which points to the previous node. So the data part is in the center and it has got 2 pointers. Okay. It's got 2 pointers. The pointer area is 2. So the node of this linked list should be something like this. I'll point a left pointer, or as you're moving previous, so we'll say previous. There's data in the center, and there is the next. The next we are familiar with the days of linear linked list. If I make a constructor of this, okay, I'll just pass the integer data to it, and it will create a new node for me with the previous as null, the data as the data, and the next as node. So this will be my node, class node. So let me copy this code and make a class node out of it. I'm switching my screen from Paint to Eclipse. I'll make a new package. Last package we made was 10. So we've been doing 10 on the last 2-3 days. So let's do the package 13 today. make a new class called as node, and this node class public class node class is there. Then if I have to create a doubly linked list, I'll have the head over here. It should be initial to null. And then I'll order for the new node. So one node will be made at the factory. I'll send the data to the node. So it will make a node as per my specifications with the data I'm sending. And the left and right, it will add null. So I said 10 as a data. So factory will add null towards the left and null towards the right and dispatch this to the site. And at the site, it will be received by the site engineer, that is NN, and installed at site 1000. So now I'll say, is my head null? Yes. I'll introduce the railway employee over here called temp. And now this point of time, the first node, the engine and the railway employee all are at the same place. So this much is pretty easy. This is self-explanatory. Now, next node. So again, I'll ask from the factory. Factory will prepare me a node and send. Let's say that node value I'm putting as 20. We'll prepare a node with 20 and return it to me. And that will come over here at address 2000. And my site engineer will now move to address 2000. And now how will I do the joining? Come on. So this should be a good exercise for you all mentally. How do I join now? So I have temp pointing to 1000. So I'll say temp dot next. I'll say 2000. So I'll say temp dot next equals to NN. So temp dot next means this part will be NN. Will be added over here. And at this part, what do I want to add? Now at this part, what do I want to add over here? This is which part? This is the previous of NN. I'll put 10. So I'll say what? NN dot previous. I'll put temp, that is 1000. So this gets added over here. And now the temp will move to the next node. So how do we increment the temp? Temp gets incremented. Temp is temp dot next. And now temp comes to this. So my list will keep on creating. So let's try to create this linked list. So I've made the node. Let's make a new class. Doubly linked list. Add main. So now if I use the node, it will be of this node. So I'll take a node head, initialize to null. I'll call the create function, pass the existing head to it. It will give me the new head. Let's create this function. Okay. So let's use scanner to ask for the number of nodes. If we have an array and we want to read all the elements from that array, then what do we do? Let's do it that way. So the no need to ask for the length of the linked list. We can take the length of that array as the length of the linked list and convert that array into a doubly linked list. So how would that be? So let me take a array and let me have these values 10, 20, 30, 40. Okay. So let me pass the array as well while creating. So you have to rewrite the function prototype. Yeah, so now I've got the array. So no need to ask the scanner and no need to ask for the data because data is already here. This should be interesting. So we're taking an array and converting it into a, eventually in the end, I'll return the head. So I'll just return the head. Now what do we do? First thing first. So first thing first, I run a loop from integer info from the ARR. Okay, so this loop will run, and in each iteration, I will get one data from this array into info. So in the first iteration, in info, I have 10. Then I'll call the node constructor and pass this info to it and ask him to deliver me a node which will be received by my site engineer NN. So now my site engineer NN has address of 1000 and data as 10, left and right is null. Okay, so please picturize and please be with me. So maybe I'll split the screen into 2 equal half and let's draw it all over again. Okay, so let's try to code it over here. So this is the current state of my linked list. So this is the array which I have passed. Let's see. Oh. So what's in info? One element from the array will come into info. So the iteration at which I am right now, in my info, I have 10. Okay, so that's over here. And my NN has ordered for a fresh node from the factory that has been delivered to it with the information as the data and left and right as null. Left and right as null and data as my info. Yeah, so this is looking pretty good. So far, so. Then what do I check now? Is my head null? Yes. Initially, my head is null. Okay. Initially, my head is null. So if my head is equal to null, So what do I do? Then I make a temp, right? So we had made a temp inside the loop last time. So we were struggling. So we will make a temp outside. Node temp equals to null. And I'll initialize the temp with the NN and the head also with the NN. So whatever is in the NN will go in the head and will go in the temp. So whatever is in the NN will go in the head and will also go in temp. Temp will also become 1. Temp will become 1. Okay, so far so good. If it goes into if, it will not go into else, and loop will continue. Next iteration, what comes into info? 20 comes into info. And I ask the factory to give me a new node with 20. So it gives me a new node with data as 20, left, right as null, delivered at the address 2000. And who is pointing over there? My site engineer. So this person now moves from year to year. And is my head null? No, will go into else. Now what to do? Do this. Temp dot next is NN. Whatever is in temp is 1000. The next of 1000 is this. This becomes NN means 2000. So the arrow gets added over here. And NN dot previous is temp. This temp. This gets removed from here. And this gets added. That is 1000. After adding, the railway employee will move ahead. So temp will come to, temp will then come from 1000, it will go to 2000, right? So what do I do? To increment the temp is temp arrow next. And once the loop completes, I'll return the head. And let's check. Then I'll call the display function. So I'll sys out display after creation, and we'll call the display with the head. This function is not there. Let's create it. Okay. Let's take the temp again and bring it back to the head. And then same. While my temp is not equal to null, this out. I'll use print over here. And I'll use temp dot data concatenate with a arrow, and then increment the temp. Dot. and then after the print, no print ln of null. Okay, let's save this. Let's run and check. Run as Java application, and we have got the linked list created and displayed. So this is how your doubly linked list actually works. Okay, so based on your doubly linked list, you can do your trees more comfortably. So if your understanding of doubly linked list is thorough, then trees should not be a much of a concern. Okay, this can go on as long as you want to create. So this was an array converted into a doubly linked list. So if I take a integer 1, 2, 3, 4, and I wish to convert this into a linked list, separate them. So how will we do that? I want the linked list to be formed with this 1, 2, 3, 4. I want a linked list like this. How would we do that? So I'll call this create from array, so that if we can create from a number, we can do so. Comment this out. And now I want to create from integer. Create from integer. And what to do now? Pass the head and the integer. So let's create this function. Can anyone tell me as to how eventually we will return the head? So this we won't do eventually. Can anyone tell me what we should be adopting over here? We will convert that into a string and then we're gonna run a while loop. Right? So if I take integer, if I just say this num equals to integer dot toString of this number, so it'll give me a string variant, right? It will give me a string of that number. So if I sys out this, let's check me. It gives me a numeric string, right? Let's just check that if it's printing me perfectly. It's printing null. Okay, that is display after creation. So this we can postpone. So it is displaying me the number, but in a string format. Yeah. So now what we can do is same logic we can apply over here. Same logic we can apply over here. Okay. Same thing. Now let's iterate through this numeric string. Okay, so this will be a numeric string dot to character array will convert it. So will give me a character array. Will give me a character at each iteration. Will give me a character info. And I'll just convert this character info into integer. Yeah, so what I've done is I've taken the numeric string, displayed it, is working fine. Then start this logic all over again. Take one from this string I counted into a character array. So now in my numeric string, I have 1, 2, 3, 4 as a string. Here, then I convert it to a array of characters. Okay. And then one character, I'm reading it in character info. And in this character info, I'm converting this 1 back to the number 1. Yes, I'm converting it back to the number 1. So let's check if it's working fine. Save it and right click. Okay, we haven't displayed it. Let's save this. Okay, see, it's giving me the ASCII value equivalent. It's giving me an ASCII value equivalent. So what did we do in that program? Minus that with the ASCII value of 0, correct? So what did we do over here? And I'm converting it into an integer. This is the get from array, right? And this is create from integer. So what I'll do is in this minus the integer value of character 0. So what is the ASCII value of character 0? 48. So 49 minus 48 will give me 1. 50 minus 48 will give me 2. Yeah, save it and run it. So I get my linked list created. Okay, so these use cases y'all can expect in your aptitude or exams. Okay, they'll give you an array and ask you to convert it to a list. They'll give you a number, ask you to convert it into a list. They might even give you a string. And ask you to convert this into a doubly linked list. So let's comment this out and let's try to add this flavor, create from string, and I'm passing the head and the S1. This function is not there. Let's create it. Okay, so let's create this. So this should be quite similar to this logic because we'll create from integer. So let's copy this code. I'll just copy this entire function. Let's see what fine tuning I can do. Okay, so I have got the string S1. So I've got the string, right? I've got the string. So I need to convert that to a character array. Okay, and now I'll be passing the character as my info. So my info now will be the character. So just make small changes in the node. That whatever info is coming now, that will not be a data, that will be a character. Just do the small fine tuning. Okay. So let's come over here. Red dot over here. Okay, then you'll have to comment out these. Okay, because these functions have changed. No. We'll comment them out. Temporary will comment them out. We'll comment these out because the node has changed. So the node has changed means these functions will not work. There was no need of making a new node. Just I change the type of that node. Let's save it. And then, yeah, makes sense. Okay. So I made a linked list out of a string. So I've showed you all the three flavors of various data types. You can create a linked list. And I also have made a linked list from an array. So from an array, from string, from a number, all that experiment we have done. So for the last few days, we've done a handsome amount of various methods. Okay. And try to cover most of the permutations which can be asked on the linked list. Okay. So let's go to trees now. Okay. So doubly, then you have doubly circular. So I get doubly circular should be self-explanatory. If I try to get W circular, so what will happen is the first node will point to the last and the last node will point to the first. So when I create a doubly circular linked list, okay, what happens over here? Let's start from the scratch. Head will be null. Head will have null. And from the factory, when I get a new node, that will have just the data and the null. And there's nothing else. So in a circular linked list, the last node points to the first and the first node points to the last. And my NN is now pointing to the first. So this is the status of my list. So I'll make a new class. Doubly circular. And I'll revert my node back to an integer. Okay. I'll revert my node back to the integer. Okay. So I'll comment this out also. Let's save it. I'll comment this out also. Right. If there's no errors, let it be. So this is my doubly circular. I have the main. Okay. Whatever common code I can copy, I'll just copy. So node null. So whatever mutual code I can get, I'll paste that. Okay. So let's create from the array, it becomes easier. Let's create from the array, it becomes easier. So create from array, head, and the ARR. And this is not there, let's create it. Display also is not there, we'll create it. Okay, so now let's say create from an array. I'm going to return the head afterwards. Return the head. Okay. Take the node temp, initialize it to null, and we'll iterate through the entire array ARR, one at a time. Okay, I'll send this to the factory, and I want a node and my NN will point to the new node. If my head is null, which it is right now, now what do I do? If my head is null, I initialize the temp and my head with the NN. Okay, so whatever is in NN goes into the temp also, goes into the head also. If it's true, this is done. It goes into if, will not go into else. Okay, now this last is pointing to the first, and the first is pointing to the last. So now last, which is my last node, the NN will always be my last node, right? NN will always be my last node. So if my NN dot next will be my head, so NN will always be my latest node. So NN dot next will always point to the head, and my first node will always be with the head. So head dot previous will always be with NN. So what is head? So let's come over here. NN dot next means this part, put the address of the first node, that is 1000. So this part is pointing to the first, that is over here. And this part now is this node will always be the first node. So head dot previous is NN. What is an NN? 1000. And this now joins over here, and it is becoming a doubly linked list. And my temp will move ahead. So I'll say, okay, this is only one single node, right? So nothing has been added, temp has been initialized. Okay, now I plus plus next info becomes 20. So I get a fresh node delivered from the factory with data 20. Okay, so this is what we need to understand. So data is 20 and left right is null. So null, 20 and null. Okay. and address of this is 2000 and has been pointed out by NA. Now, is my head null? No. To go in else, what to do? So wherever the temp is, in the temp dot next, you put the NN. What is buffering? What I do to cancel this? Has gone into, okay, remove. Yeah, perfect. Here it was. So now it ends. Where is temp 1000? Temp dot next will be NN. So I'll do this first. 2000. So this will be removed from here. And we add it to here. So what did I just do? First thing, temp dot next equals to NN. NN dot previous equals to temp. NN dot previous equals to temp. So this is removed. And this will have 1000. And this now joins over here. And now this first dot previous should go to NN. The first is with head. So head dot previous will go to NN. This will be removed. Head dot previous will go to NN means this will go here. So that will become 2000. And NN dot next will become head. So this code seems to be mutual. This code seems to be mutual for both of them. So I'll cut it and I'll put it after the loop because it becomes mutual for both of them. So no need to write it except separately. Yeah. So I guess this should create the doubly linked list. Let's try one more. Okay, then no. Oh, here I have to do one more thing. You have to increment the temp. This task we have to. Temp is temp dot next. Yeah. So temp now goes to where it's next. What is the next of temp? 2000. So temp comes to 2000. Let's just repeat one more iteration and see if it's working fine. Okay, and then what did we do over here? NN dot next becomes the head, right? What is the head? It is constantly forming a circular loop. And head at 2000 loop finishes. I go up, I make a order a fresh node. Let's just try run this one, and if it's all good, then we can say creation is good. So it will pass 30 to it. And address 3000. Shift the NN over there. Left, right is null. Oh, it had null, no. Temp dot next. Temp is 2000. So 2000 dot next means this part is NN. NN is 3000. NN dot previous means this part is temp. That's 2000. So now this has been removed. This has been removed. It's been added to here. And this has been added to here. Okay. And now this head dot next. NN dot next means this part. NN dot next means this part. Will have head means 1000. We will join this over here. That one. And head dot previous is NN. Head dot previous was 2000. Now it becomes NN, is 3000. So this then goes over here. Okay. And temp is temp arrow next. Temp is temp arrow next. Temp goes to 3 points. Okay, now how do we display it now? So if we have to display this, we'll bring the temp back to the start. So temp comes back to the head. Temp comes back to the head. And it has 1000. So what to do? So let's do a do while over here. Let's try. Display me the temp dot data followed by a arrow sign. Okay, so it will display me first 10 and then increment by 10. Increment by temp. Temp dot temp equals to temp dot next. So temp now goes to 2000. And while my temp, so you were checking for null, right? We'll check for 1000 now. 1000 is with head. While my temp is not equal to the head, we will iterate this. So 2000 is not equal to 1000. Yes, true. Go inside and display temp arrow data. Display 20. And then temp is temp arrow next. temp goes to 3000. 3000 is not equal to head. Yes, true. Go inside. Display temp arrow data, that is 30. And then go to temp arrow next. Temp becomes 1000 then. Once my temp becomes 1000, I will check 1000 not equal to 1000, loop will break. And I will, okay, so there is no need to display null over here because this loop will be circular in nature. So let's check this out. I save it and let's run and check if it's working fine. Okay, I gave a ln. I should have given only a print. Yes, so it's working perfectly fine. We are good to go with a doubly circular as well. So here I should have displayed 10 again, right? Yeah, I should have displayed 10 again. So once it breaks, I'll display the temp.data outside also. So once my loop breaks, I'll display the temp.data even outside so that we get the flavor of circular. It's starting at 10 and again ending at 10. Yes, guys, all good. So we've covered all the major linked lists. So if you can do doubly circular, we can do the singly circular more efficiently. Amar sir has shared you all the attendance. Those who have not marked the attendance, please mark. Meanwhile, I'll push this port and let's check a round of YouTube and check what those guys are doing. If they have any concerns or questions, let me address that. All good, guys. Those who joined online understood the concept, right? Clearly. Of doubly linked list creation and all the various flavors. I've tried to create linked list from all the type of data and doubly linked list. All good for the guys who joined to YouTube. Let me push this code and share all the links again. If you can send in your feedbacks and the questions, queries you'll have. I hope you are benefiting from these sessions. You can put it onto the chat as to how beneficial these have been. Any other feedback you would want to share? These are the this is a repository link for the YouTube guys, and this is the repository link for the Zoom guys. Okay, we still have 5 minutes, so I'll just give you a heads up of the next topic which I'll be covering. Okay, so that would be your trees. Okay, so we have 2 more sessions and we need to cover trees. So all this what we were studying was linear data structures. They would go in one line. What is the difference between linear and non-linear data structure? In linear data structure such as arrays and linked list, every element has one predecessor and one successor. So if I can use that drawing, no. So every element will have one predecessor and one successor only. So in a linked list like this, whether it is doubly or singly, doesn't matter. So if I have element A, B, and C, A is at 1000, B at 2000, and C at 3000. It is, so how many successor of A? How many elements immediately after A? Only one element. And how many element immediately after B? Only one element. So single successor and single predecessor. So where is B taking from? So B is taking from A. So A is the predecessor of B. And who is B giving to? C. So C is the successor of B. So single predecessor, single successor. So such type of DS are called as linear data structures. But when we come to trees and graph, they are called non-linear because in a tree, there can be one predecessor, but we can have multiple successors. This is a tree, edges and vertex, okay? So the round is called as the vertex and the line is called as the edge. So a tree is a set of vertex and edges. Okay, so like this. So like this, you can form a tree. Correct? So if I name them A, B, C, T, and E. So let's take A now. Okay, let's take B as we had taken earlier over here also. How many predecessor? Single predecessor. So B is taking from one person. That is A is giving to B. But how many successors of B? B is passing it on to how many people? So B is passing it on to multiple successors. So such a data structure, when we have more than one successor or more than one predecessor, is called as non-linear. So tree and graph, they fall into non-linear, and arrays and linked lists fall under the linear data structure. Okay, makes sense? So we'll stop here for this discussion. Next, we are meeting on Monday. And on Monday, we'll continue from here and we'll try to implement non-linear data structure. As I told, I also want to spend some time on hash map. So we'll try to juggle between tree and hash map and try to solve some more real-time questions. Sir has shared the link with you all for the attendance. Please mark your attendance for the day. And then next, we are meeting now on Monday. Right, Amar sir?
Yes, sir, right.
Okay. Thank you, guys. Have a nice weekend. Take care. Bye.